My name's Lee Ragg. I am the product manager, sales specialist for our Seamatic Ident range. And I'm here today with my colleague Fergus Sykes. I'll let him introduce himself quickly.
Hi there everyone, I'm Fergus Sykes, automation specialist for Seamatic Ident. So I sit within our technical support team, normally in Manchester, but obviously all at home at the moment, delivering these to you from our remote offices.
Cheers, Fergus. So what we're going to do today, the agenda's there on the right-hand side. We're going to give a quick introduction. What is Seamatic Ident and our product portfolio? That includes our OID business, our RFID business, and then I'll hand over to Fergus, who'll give you a live demo on something that's quite new from us. So we'll show you our new camera, our new MV500 product with our location light firmware. And then we'll talk about some application examples that we see in the field today, and then we'll take some questions and answers at the end. Okay, so if we crack straight onto it. So Seamatic Ident, for people that don't know, we have been 30 years in this technology. So we've been around for a long time with our industrial identification. We break the business up into three silos, if you like now. We have our OID business, which is our optical identification, which is our smart cameras. We have our RFID business, where we manufacture two types of RFID. We have our HF technology and we have our UHF technology, predominantly HF, small reading range, lots of data with inside the tag, normally one tag at a time, normally found within the sort of powertrain sector of the automotive world. UHF business to read multiple tags over larger distances up to 9 meters potentially, and obviously sort of for more the logistics sector. And our new business that we'll talk more about tomorrow, we're going to do a separate session for this, is our RTLS business. So we have a real-time locating systems that we'll talk to you in a bit more detail tomorrow. But for today, let's dive into OID to start with. So OID, we manufacture smart cameras. Okay, so our optical identification business is our smart cameras, which are out the box from the factory, predominantly barcode readers that would read linear barcodes right the way through to data matrix barcodes, to QR barcodes. Not only can we read black on white, high contrast printed codes on labels, but we also have the ability to do DPM, so what we call direct part marking. So whether the component is laser etched or dot peened or chemi etched, whatever inkjet, whatever sort of marking method to obviously put a barcode down onto on a product, we have the ability to decode it straight from the MV500. We have some software plugins which turns the reader into more than just a code reader. We have the option to do OCR, so some optical character recognition, and we have the option to do simplistic vision that we'll come on to talk about in a second. So what are our software add-ons? So our software add-ons is Location Light, which is new. So this has been released this month. So we'll talk in a bit more detail about this, which comes now as part of the MV500 product. So at the factory, you get Location Light as well as a code reader, and it's our sort of entry-level simple object recognition that we'll show you a little bit more later. Then we can obviously have a software license upgrade, so we can upgrade the camera to do Pat Genius, which is a full license for vision systems, for detection, positioning, counting, presence, absence, some what we call simplistic vision tasks. So I have to point out that we don't manufacture in-depth PC-based vision. You know, all of our vision systems are around the smart camera portfolio. We have another software which is our Text Genius license. So this enables us to read black on white, high printed OCR on labels. This could be OCR A, OCR B fonts, black and white printed. We also have our Text Genius Plus license, which gives us the ability to train different fonts and special characters to potentially read inkjet codes on best before dates on pharma packaging, food and beverage packaging, etc. So different ways to print the code. And finally, our final software upgrade is our Very Genius license. So this gives the camera the ability to verify the quality of barcode. So, if you print a barcode and not only do you want to read it, you want to verify the quality of it to ANSI or to ISO metrics. We have the ability to do this both on linear 1D barcodes and 2D barcodes. So those are our software license enabled. So it's the same product, the same camera out the factory that comes as a code reader. But let's just say you're reading a barcode to start with, but in 6 months' time, you want to read the human readable printed along the side of the barcode. You want to verify the barcode. You want to do something clever with presence absence, or you want to check that the label's actually on square on a product. Literally, it's a software license upgrade. You don't need to buy a new product. It's not new hardware. You're not stuck with something that maybe no use anymore. You can literally just buy a license plugin, and it will future-proof the camera for you for different applications. So let's have a deep look into our product portfolio now. So on the left-hand side, here's our legacy sort of Simatic MV400 products. So we start with the MV420, which is our entry-level, small form factor, low cost, black on white, code reader. Then we move up to our MV440, which is our high performance camera, which has the ability for the 4 software license plugins. We do have to sort of point out that the 440 has been around a little bit now, so we're sort of migrating now from the 440 to the MV500 product. So this is the new one that we want to talk to you about a little bit more today. So our MV500 is our new range of smart cameras. That there is some improved lighting, some improved lens, and we'll talk about some feature benefits in a second of the new camera. You'll see that there's 3 different models, and we'll explain to you what the different models are. And on the right hand side is our handheld reader business. So we do have a USB standard wired handheld to do 1D 2D codes, and we have a cordless Bluetooth scanner as well. Again, these products can read black on white high contrast labels, but also can read DPM, some laser marked parts on metal surfaces. Let me go back a second to the MV500. So some distances for the MV500 is we start with our MV540, which is our entry level camera, which move up from the 440 product. So like I say, some feature benefits there. In terms of the lighting's improved. We have an e-focus lens now, so we can actually dynamically change the focus of the lens. We have an SD card in there for parameter saving, and we also have an easy setup button at the top, which enables you literally to plug the camera in, press the setup button on the top, and it will automatically set the camera up for the correct focus, the correct lighting, and you're literally up within seconds to actually start reading barcodes. And you'll find that it's probably about 3 times the speed than what the 440 is. Okay, so it enables us to do high speed code reading in sort of maybe some logistics applications. Our RFID business, our radio frequency identification business, quick, how does it work? So within RFID, we manufacture, like I said, the 2 types, HF and UHF. They are passive RFID, so that there's no battery involved. And a quick explanation of how that works. So we have a reader that literally sends sort of energy out. The tag sees that, the tag gets quite excited, powers the tag, and then it sends its data back wirelessly to the reader. And we have multiple products for that. Like I say, the two products that we produce is 13.56 megahertz in the high frequency bandwidth and 868.915 megahertz in the UHF bandwidth. So some people may know we have our RF200 range, which is our sort of entry level HF, which you would see again on automotive powertrains. We have our RF300, and we have our access control reader, which is our log-on reader. And obviously the UHF product is what we call our RF600. And again, sort of some similar distances between the two. Predominantly short read range on the HF to sort of long read range on the 600. Lots of data in the tag within HF, not so much data in the tag of the 600. But again, multiple tags with RF600, predominantly one at a time on the HF portfolio. So when we talk about tag selection, it's something that we talk to our account managers about. We like to use this word success, and these are the sort of 7 questions predominantly that, we would ask our account manager or a particular customer about an RF application, because it's important we get the tag right first before we move obviously onto the reading side. So these are the sort of 7 questions that we would ask a particular application. How much memory would you require in the tag? How much data do you want to store? What material would it be attached to? Are there any special conditions in terms of, is it a heat? Has it got to do a high heat process? Are the tags going to be single use? Are they going to be used multiple times? What sort of read distance predominantly would you be looking for? And is there any sort of space requirements, specifics that we should be aware of? So if we answer these 7 questions, then that would put us in a good position to spec the right RFID transponder, and then to give us a way of moving forward with a particular application. Just show you some products now within the RF200 range to start with. Readers start from literally as small as a sort of a barrel photocell reader, right the way up to a much more larger reader that can have external antennas. We have readers that just readers only with an internal antenna, and we also have the option to plug in external antennas. If you needed to maybe have a conveyor and you didn't know where the tag was going to come, you might have the reader on the left side, but you might need to put an antenna on the right side to read the tag without necessarily going through to having 2 different readers. We have an option of turning the barrel photocell into a sort of mobile handheld, and there you see our transponders on the right hand side start with access control for the RF1000 log-on reader, right the way up to industrial tags that can be screwed into engine blocks, stuck on plastic pallets, whatever the sort of application is. There's normally a transponder that would suit the requirements. On our RF300 range, again, very similar that you'll see that we have a dedicated handheld though, in terms of the readers with the RF300. You will see some different sort of tags. This is our high temperature tag for paint shops. So you'll see some different compact readers, and some people that know the SIMATIC portfolio from years gone by, this is also known as our Mobi E or Mobi I sort of just transponders that are still that you see in the field today. So that's our RF 300 range. Our RF 600, our UHF portfolio, again you will see sort of readers on the left hand side. We have antennas to go with them. So again, we start where we have a fairly new reader. We have an RF 615, which is a small compact single node reader now, that literally is quite small, quite nice for a conveyor application, that can come with either an integral antenna or one external antenna. And we go right the way up to our RF685, our industrial reader that can take up to 4 external antennas. So the sort of application we would use there is sort of a logistics reading gate, where we'd have multiple antennas, sort of 2 on the left, 2 on the right, position them over a loading bay so a forklift truck could drive through, and then we could capture everything that was on the forklift trucks. That's what we call our reading gate portal business. And again, we have an option of a handheld RFID reader in the portfolio, as well as tags. So we do have self-adhesive sticky label RFID tags, so normal white paper labels with an inlay in there that will just go through your normal thermal transfer printer, so you can still print, and then obviously can be adhered to the side of the product, right the way up again to what we call our industrial tags. Again, tags that are being screwed into engine blocks or plastic totes or whatever the sort of application was. We will have a tag for the for the project. So our RF1000 product again is a HF reader. So this is what we call our log-on reader. So this primarily can plug into any of our HMI comfort panels. So rather than an operator literally type in the password into the HMI, they can actually use their employee card. So it's quite good in terms of customers could still have their existing employee badge that gets them onto site. They can use that card to log on to the HMI. I know there's some security things now where some people know each other's passwords, so it's a good option to use their existing employee card, log on to the HMI rather than needing to type in passwords. So that's how a RF1000 sort of entry-level scanner for HMI log on access control. I'll turn over to Fergus a second now. Fergus will talk to us about how our ident products interface with our sort of TIA portals and PLCs. So over to you, Fergus, on the TIA side.
Thanks very much, Lee. So yes, essentially integrating into TIA portal, it's obviously a massive priority for Siemens, getting everything into our totally integrated automation portal. And ident is no exception. It's actually been integrated into our control systems for a long time using a block called the ident profile block. But we now have a number of different wrappers for that block, which make that interface far easier. And we're going to show this in the demo. Some of the devices can connect directly onto Profinet. So the RF600, for example, straight onto Profinet, drop it into your hardware configuration. There's an ident technology object, which provides the interface for that reader. And then you can start communicating with it with some pre-built blocks. With some of the other devices, the cameras as well, by the way, are straight onto Profinet. With some of the other RFID readers, they do have to go through a communications module. There's an absolute plethora of options for this depending on what sort of I/O you're using. So we've got ET200 on the left. We've got our distributed ET200S or SP, ET200 Pro, which is more distributed IP rated. We've got S7-1200 form factor. We've got down on the right hand side, the RF160C, ASM456 if you want to go onto Profibus. All sorts of options for connecting into a TIA portal environment and interfacing with our controllers. And like I say, we'll go into a demo of that shortly.
Okay, cool. Thanks, Fergus. There you go. You sort of knew it was coming.
I told you it was shortly.
Yeah.
Okay. Do you want to stop sharing then, Lee? And I'll take over.
There you go.
Thank you very much. So could somebody just give me feedback to make sure that you can see my screen here with TIA portal and the camera?
Yep.
Perfect. Thank you very much. So this isn't a picture on the right. This is actually a live video feed, so you can see my hand there, just so that you've got a little bit of a physical representation of what we're actually looking at. So what we're going to do here today is we're going to connect our 1500 up to our MV500. So this is a 560U in this case. It's not required necessarily for this application. The U is a fairly high spec one. It's just I couldn't bring one of every single camera back to my home office. Otherwise, my girlfriend would be a little bit upset with all the boxes. We've also then got a little RFID reader down at the bottom here, which we're going to be looking at with our camera and identifying the screw holes and passing the coordinates of those screw holes into our 1500. So I will just spin back round. Okay, let's add in our 1500. So I'm going to pick an unspecified CPU in this case and do the detect because I can't remember the exact part number of my CPU, and why bother going to the effort if the software can do it for me. That's the power of the integrated software systems, I guess. Here we go. So this loads up. I'll do detect. Fingers crossed. I have tested this multiple times over the last couple of days, but you never know with live demos. Start search. Found our device. I'm just going to detect that 1500 and bring it into the project. You can also do this with I/O, for example, like ET200SP racks, by the way, if you weren't aware, using the hardware detection. But for our camera, I'm going to go into detecting and monitoring in the hardware catalog and our Simatic optical identification systems. You can see there we've got a representative for each of the families, and I'm going to drop in my MV500 here. Currently there's no firmware differences available. There is actually a firmware released that updates for the locator light, which we're going to be looking at, which is a no-cost option. but this older firmware version GSD file is going to work just fine for us for the moment. So I'm just going to go into the properties quickly. There's a few different options in here, but the only one I'm really concerned with is this operating mode. So FB79 and ident profile are two different ways of communicating with the camera. We don't really need to go into the depth, but for the technology object, which I would always advise you use if you're just doing a simple quick setup, we want the ident profile. My IP address here is going to be 0.2, and the IP of my controller is 0.1, which I have already preset with ProNetter ahead of time, just to speed that up a little bit. But what I do need to just do is assign my device name. Apologies if I'm going a little bit quickly. I just want to make sure that we get everything into this this demo, and we don't want to keep you here for too long. I'm sure everybody needs to go and tend to children and dogs and things like that. So I'll just assign the device name. There we go. And I'm just going to download the hardware configuration to the controller for now. Just so that once we've got that hardware downloaded to the controller, it can go out looking on its Profinet network, find the device name that we've just assigned, and connect up with the MV500. And we've got more stable lights now on our 1500. I'll just finish loading that. Let's turn the screen back on. There we go, downloading process. And let's start the module. And there you go, we've got a nice green banner. Okay, so what we're now going to go into is the camera software. So we can do that from here. We can just type in an IP address into any web browser. This is essentially a link for the web browser, the IP address that we've specified, and that will bring you to this page. So I've already loaded this up prior, so there you go, there's our IP address up there. To go into the sort of main home page, I'm going to click on our camera, and I'm going to log on. As with everything in the world that we currently live in, security is a priority. The default password, I'm going to log in with service, is just service, but you can of course change all of that, and if you log in with admin, you will be forced to change the password to increase that security. First thing that we're going to do here, if we go to communication, you can see we've got Profinet ident profile selected up there, and I'm just going to change our trigger source to Profinet IO so that we're looking for a Profinet trigger, and then all of our results are also going to be via Profinet IO. I'm going to save that up here. There's all sorts of different options for communication, as you can see. We're not going to go into everything today, we just don't have time, unfortunately. But you want to see the interesting bit. Now, apologies if anybody's sensitive to flashing lights, but this on the right-hand side will be flashing a little bit while I'm on the sort of auto trigger mode. So, takes us to this screen. We've got a basic program input into here. The first step of which is always image acquisition. Then we've got a decoder step, which we don't actually need in this case because we're going to do location. And then we've got our result, which is the output. So for now, I'm going to just remove that decoder step, drag it to the bin, and I'm going to drag in a locator step to the middle. The reason that these are drag and droppable is because you can have multiple steps of different types. So you can use, for example, a locator step to find a label within an image and then decode on that label, which could result in reduced decode times compared to just scanning an entire image for barcodes. Or you could have multiple locator steps if you wanted to, multiple decode steps, whatever you'd like to do. So what are we going to do? In this step, our objective, I'm just going to zoom in here a little bit, is to find, as you can see on our Simatic RF240R that we have here, we want to find these screw holes. So what I'm going to do first is create a model. So we flick this over to Object ROI, and we get this little box here. Wherever you see this box in any of these screens, it's known as an ROI or region of interest. Now, the region of interest can be increased or decreased. If you're doing something like code reading, you could have it as the entire screen, but if you left it as the entire screen, you'd probably end up taking far too long to find your code. Generally speaking, you want to adjust it as narrow as you can so that the camera doesn't have to look at every single pixel on the screen. And I'm going to be looking for this little screw hole up here. I'm going to try and get that dot as central as possible. There we go, that'll do. So I'll just bring this in actually a little bit. That looks pretty good to our human eyes, but what we can see in the background here, this is on a wooden table, and we've got a lot of sort of interference in the background. Lots of different lines, lots of different edges, effectively, of contrast difference, which is what the camera's looking at. And the more complicated the image, the longer it'll take and the more tricky it'll be for the camera. So what we're going to do, first of all, is go into our image acquisition and play around with our capture. So at the moment, we've got the exposure on auto. And so every time it takes a picture, it's actually taking multiple pictures and adjusting the exposure time and brightness accordingly. We're actually going to put it in manual for the moment. And it's just taken those the details from the last image that it took. And we can adjust this as we please. So you can see if I turn the exposure time down, we start to get darker. Exposure time is literally the amount of time that the sensor is exposed to light. So the longer it's exposed, the more light it absorbs. And I happen to know that 1800 is a good value for this, along with 100 for our brightness, which is sort of an artificial sort of like gain value in a way. Now this image looks really blown out. To our human eye that looks rubbish, but actually from the camera's point of view, all it's interested in is these objects up here, and now we have a nice sort of crisp edge against a plain white background, much easier to find. What we have down here as well, you can see, is our e-focus. So I'll just stop this flashing for a moment and show you something quickly. So in front of the camera now, you should see we have a little lens. So this is one of our fixed lenses that could be on this camera. And normally you would adjust your focus with this ring on the end and your aperture with this ring lower down. We don't have to do that in this case because we have an e-focus lens. So if you look at the image that we have here, I'll actually just put this back onto auto so that you can see the text. And if I go into manual, I just need to put that back to trigger. So we can read this text at the moment. I can now change the focus with this value, and you see that changes there. I don't need to worry about that at the moment, and in fact actually for object recognition sometimes defocusing is actually better because it simplifies the image again, just like we've done with our exposure. But I'm just going to leave that as is for now. The beauty of this, by the way, is that you can leave it set up with different focuses for different programs. So say you have different products coming down your line, which are different heights, for example. Those products could all be scanned, and when that program is loaded in, you can have up to 16 programs, I believe. Once that program's loaded in, the focus will be set appropriately for that object. We also have lighting options down here. In this case, we just have a standard unpolarized light. But if we had a filter on the end of this, we could actually have a polarized beam, an unpolarized beam, and a main beam. And we can, again, select different lights for different capture stages. And the camera can then dynamically adjust itself as we go through the program. Perhaps if we've got variable lighting conditions in the environment, we can adjust for that by taking multiple pictures with different lighting, different exposures, different focus. Okay, sorry, just having a drink. Okay, so now that we've got a more simple image, let's create our model. And you can see there we've highlighted those lines. So the locator has identified these edges and it's saved those as a model. I'm going to swap over to the search ROI now, and I'm going to make this our entire screen. And what I'm going to do straight away, formation of result. There we go. We've found that. So we're continually taking images at the moment, and we found our screw hole. And you can see as I move this around, we can track it around the image. What I'm now going to do is set this up so that we can find the other hole as well. So if we go for number of objects 2, and I'm going to allow a little bit of a scale difference from our object that we've trained it with. And of course, because it's upside down, we need to allow some rotation, or a lot of rotation, in this case 360 degrees of rotation. If we now go back, there we go, we found both holes. So there you can see, as we move around, we're tracking both of those screw holes, and we're actually getting the coordinates down here. Now this doesn't look like much at the moment, but all shall be explained. So we have what we called the format text here. I'm just going to quickly format this a little bit. I won't go into too much detail because there's all sorts of things that we can define here, but essentially this is the string that will be sent to our PLC. That's all you need to know. That's the string that we're looking at that will actually be sent to the PLC. And with all of these setups, by the way, in essence, your PLC will always get an array of bytes, and then you can do with it as you please. That makes the interface much, much simpler. If you're connecting to a PC system, you can now also actually retrieve the images as well as diagnostics logs and things like that if you want them. So for the format here, I'm just going to put some extra characters in here that are going to make sure that our format is always 4 digits long. I'm going to delete the rest of this bit. I'm just going to add in some dividers. I'm going to call that Y, and I'm going to call this X. There we go. So you can now see in our format, we've got X 348, Y minus 357, X 271, and Y 333. Those values don't seem to make much sense really at the moment, but essentially those are in reference to our center point. So you can see the center point here, the black dot, the center point of our region of interest that we defined in the model, which was why I was so careful with getting that dot right in the center of our screw hole. That is the reference, that is what we're referencing to this center point. So the coordinates are that central point of the model referenced against this center point, which is why some of them are negative. We do get some other information in here at the moment. We're not too bothered about rotation because it's a hole. We don't really need to know what the rotation of it is. We just need to know there's 2 and we need to know where they are. So that's essentially it for our model. We've created that. We don't want to change anything in the results step at this moment in time. So we're just going to save our program. So I will just save this as screw hole find. Save program. Okay. And collapse that, and I'm going to go into play. So at the moment, we're on single trigger mode, which is the default. So we haven't actually got anything to look at the moment. So I'm just going to log off now, and we're going to go back to TIA Portal. So how do we actually control the camera? The technology objects that I was talking about before, here they are. So we've got motion control, which a lot of people will be familiar with, PID, counting and measurement. We also have somatic ident. TO tag layout is something that is still slightly in development, but this will provide essentially custom, easy to use tag layouts for putting user data onto RFID tags, which is a really nice feature. Just makes the data handling a lot easier. But we're just going to use a TO_ident for connecting up our camera. If I put one of these into our project, and as we do if we're selecting a drive in a motion object, we just go into our devices, distributed I/O, ident profile, and tick that. And that's all there really is to do in this technology object. We can, if we like, define it so that when we issue a reset command, it always selects one of the programs. We're not going to do that for the moment. I'm just going to leave that as is and go straight into my main OB. So what are these blocks I've been talking about? If we go down into our optional packages, which is a lovely new folder we've got now with all sorts of goodies in there, we also have somatic ident. Now there's loads and loads of blocks in here depending on what objects you're using. So we've got RF600s, 300s, we've got camera stuff, advanced blocks. We don't need any of that in this instance. All we're going to use is a reset reader, which, as it says in the name, is used for resetting, acknowledging faults, that sort of thing. We're going to get a set program. So this is how you'd choose which program within the camera that you want to run at any time. And we're going to get a read MV. Drop those in. I'll just minimize that. Okay, we're then going to drop our somatic ident technology object onto our hardware connect pins. And it's as simple as that for addressing it. There's no more faffing around with hardware numbers, hardware IDs. We don't have to deal with the comms at all. It's as simple as that, dragging and dropping the technology object onto the block. The only thing left now is to create a data block for our data to be stored in. So I'm going to create a new DB here. I'm by no means showing best programming practices, by the way. This is just a simple setup, so please don't judge my programming skills. I am going to create an array here for our data. Doesn't really matter how big it is, it just needs to be big enough for the data that's coming back. And as I said before, it's just an array of bytes. So there we go, we've got 500 bytes in our array. Come back into our program. I'm going to highlight our data block, and in the details view, I'm going to drag the array, not the data block. I'm going to drag the whole array onto our ident data pin. And that is literally all we need to do to start getting data back from the camera. Thanks very much, everyone. I said, no, obviously I'm going to actually show you it working. I'm not going to cop out there. I'm just going to pray that my live demo actually works. Here we go. Let's download our program. And I've opened up a watch table here. I'm going to quickly drag in our executes. So if I go into program resources, reset reader, and we'll go execute and set MV. We want the execute for that as well. And read. I'll get the execute for that as well. Expand those out a little bit. And then I'm going to use the split window function and open up our data block below so that we can see the data when it arrives. So let's go online. And you can see we've currently got nothing in our data block. And if we go online here, everything's happy and healthy. We're connected up. We just need to try and trigger the camera. So I'm going to do a quick reset. I'm going to set our program as 1. And fingers crossed, there we go. We have data into our PLC straight away. Now, I'm going to say that you're probably not going to believe me that this is actually the correct data, because that looks nothing like what we were actually looking at previously in the camera software. I'm just going to do a little bit of data manipulation using some code that I've written previously so that you don't have to watch me do it all. Excuse my little cheat sheet here. I'm just going to quickly drop in all this data. Just grab that one as well. Come on. Why is that one not dropping in? Okay, got my string in there. And then I'm going to go into my main OB and just drop in a little bit of SCL code, which is going to turn our data into something that we might recognize. You don't have to do this. It entirely depends what you want to do with the data you're being sent. You may not want to manipulate it at all. You may want to keep it in those segregated bytes. But just so that we've got something that looks more human readable, I'm going to convert it for us. So this is a little routine that will allow us to auto trigger as fast as possible once we get this set up. And then this routine simply looks at the string. The first 2 bytes are the length of the string. So we're going to find that length. Then we're going to move all our bytes and convert them with a chars to string block. So this is the block that's doing the conversion. And we're going to tell it how long the string is and then convert it over. So I'm just going to define this tag. Again, not programming best practice here. I'm just trying to show a simple example. And we obviously need to change the ident data connection here. Ident data all bytes. I'll put that on there. And that's our code done. Now I'll just go into, download it first, and then I'll just go into the watch table and add in the new elements. Reinitialize our data block because we've changed all of its contents. Right, minimize that. Here's our watch table. I'm just going to delete those out. And if we just delete all that, and I'll pull in these elements. This is the bottom one. So I'm just going to expand these out a little bit so that we can see it. Okay, let's go online and go to play. Bring the camera view back up here. So there we go, everything's off at the moment. We currently don't have a string. Sorry about that, my headset just turned itself off. We're back. Okay, so we're going to execute our reset program set, which we don't really need to do because we've already done it. And we're going to take an image, and there is our readable text. And what we'll also do now, we'll put the auto trigger on so that it's constantly pulsing. And as you can see, as I move this around, we've now got our X and Y coordinates for both of those screw holes in the camera, in the PLC. Just to show you what that looks like from the camera's point of view as well, we have these web pages here which don't require any sort of access to the camera, so we're not disturbing it too much. And I'm just going to bring that down here, move that across a little bit, and there you go. You can see our two screw holes there. And now there you go. You've got three different views. You've got the live view, you've got the camera, and you've got the coordinates within the PLC itself. I think I'm going to call that a successful live demonstration, and I'm going to hand back over now to go over quickly some application and use case examples from our customers. Thank you very much.
Thanks, Fergus. Fantastic. Let's drop back into this PowerPoint. Okay. So hopefully, yeah, Fergus showed you there basically our new Simatic MV500 product. So it's been a long time coming for us, but now we have a product which we believe is best in class. Like we say, it's high performance, dual core processor. You know, so some features there. The one button setup at the top that you can see, the SD card, the lighting, the liquid lens, the e-focus lens. As Fergus pointed out, we have obviously PoE now from the camera. And just to give you a quick idea, so this is the entry-level 540, okay, that you'll see with Power I/O connector and a high-speed Ethernet port. The 550 range adds a second high-speed Ethernet port, which is quite a good USP for us as Siemens, because if we're using the Ethernet port to communicate with the PLC over Profinet, we may want to use the second high-speed Ethernet port for failed images. So we might want to have a look at the failed images. And our 560 has literally just been released in the last week or so. Our 560X is our logistics camera. So that allows us to look at high speed code reading on sortations, aircraft baggage, etc. So we have a logistics. And so a 540 entry level with location light, 550 extra high-speed Ethernet port, 560 our logistics reader. So as Fergus said, we're going to take a quick spin now, the last couple of minutes, through some particular applications, and then we'll wrap up and take some questions. So here's an application for an automatic weighing for a customer. So you'll see the RF1000 for the operators logged on to the HMI. You'll see a HMI panel, a PLC. The box comes into the station. We weigh the weight of the box and then write the information to the RFID tag on the label, and it moves along to the next station. It's a particular application that we do quite a lot of. This is a sort of a pharmaceutical company that want to track their vessels, if you like, for sterilization. So again, we have an RFID transponder on the vessel. It comes into the station. We read the RFID tag, send it on its merry way, and it gets sterilized. Next vessel comes in. We read the RFID tag again, find out that it's already been sterilized, and then we can send it back the way, so we don't need to do the that's a live application. sort of returnable packaging, a good example. So again, an RFID transponder on a plastic tote that comes into a station. We can read the RFID code on the tote and send it on its merry way. We know another one comes into the station that's empty. So again, we know it's empty when we read the RFID tag and can send it away. And hopefully in a second you'll see an RFID. There you go. And then all the empty containers go back into the stores, and you'll see an RTLS transponder onto the forklift truck. So we read on the front of the truck, we read all the RFID tags within the plastic totes, and then we can then use the RTLS transponder to track where those totes have gone within a factory. So an ingredients verification application for a food and bev chem company, again using RFID, where we can read the tag to make sure it's got the correct ingredients in. Some tool identification, so again we can use the barrel RFID 200 reader, so we can read the tool to make sure the right tool's gone in the right fixture. So we use that for what we call change parts. So if people are changing parts within a machine, we can make sure we've got the two parts that match before we actually start the machine, so the machine doesn't break down. Again, some production control. Again, this is an automotive company that has LaserMark 2D codes on. Comes into the station, the robot puts the cap on, it goes along, and then we have the MV500 that reads the data matrix code, and then it goes along to be read by an RFID reader placed on. And again, you'll see the pallets at the back, and you'll see each metal stillage, if you like, has an RTLS transponder on to track it across the factory. Here's an RF600 application that we've seen lots of inquiries for within logistics. So this is what I call about reading gates. Remember me explaining earlier on, we have a reader with 4 antennas, 2 on the left, 2 on the right. So we use this for loading bays. So literally we can do inbound logistics and outbound logistics, where we can read all the boxes on the forks of a truck. So we can do a quick goods receipt note when things arrive in a warehouse. We can do a quick goods receipt RFID instead of manual scanning. And obviously when things get shipped onto the truck, we can obviously do an outbound logistics check, so we can get an accurate count of what's gone onto the truck. And that's it with some, I think we're bang on 50 minutes. There you go. Couldn't time it any better. So that's it. So hand over back to Damien, and if anyone has any questions for me or Fergus, we're happy to take them. Our email addresses are there if you want to note them down. If you want to, take anything offline, if you've got any particular questions, then by all means. But yeah, we have 5 or 10 minutes left if you want to ask us any questions.